Hello everyone, and welcome back to another Heartwell dev stream, the live stream series where I continue to develop this adorable Souls-like action RPG with platforming mechanics and a branching narrative. If you find these dev streams interesting or helpful, be sure to subscribe to the YouTube channel and boot that bell button to stay notified. Now, in the last stream, as you can see here, we were busy working on some pathfinding, and so far we've gotten our little collision boxes to do a couple of things. So what you're seeing here is just what the enemies do when we're not in an area that they can reach. We can walk past these rectangles here, but the enemies can't. But once they have line of sight, they move towards us as normal, as though they are just standard blocking enemy. Now, we haven't quite been able to get it work. So we managed to do this, and they act independently of one another, so you'll notice that they don't always move in sync, I mean, they don't move in sync at all, as you can see. That one's, of course, moving independently of the other one, and so on and so forth, which is very important. Hey, KK Sparks, thanks for dropping by. How's it going? Ooh, cinnamon buns. That sounds delicious. Hope you enjoy, KK Sparks. As I was saying, so we managed to get to a point where we can have enemies move in, we'll say, multi-directional movement, simple pathfinding, and act independently of each other and scope correctly. And that's a very big deal, because that was something that was a huge trouble spot with the pathfinding algorithm in Heartwell. So it's a good first step. What we tried to do last stream was to make it, you see these little green boxes here, we tried to make it so that these enemies would path to those boxes when they can't see the player, so that they could get around corners more easily. Managed to get that working for, we'll say, one enemy, or one of these boxes, with multiple enemies moving to the same box, which is okay, but we weren't able to scope it quite correctly with multiple boxes and multiple enemies, and trying to get, like, one enemy to path to one box, and one enemy to path to a different box, and so on and so forth. So, in terms of, oh, hey, Copper Nicholson, thanks for dropping by. How's it going, dude? So, in terms of what we'll be trying to accomplish tonight, we will be trying to further refine this pathfinding algorithm so that the enemies are hopefully able to get around corners like this when they can't quite see us. So what I would want is to end up in a situation where enemies chasing me around the corner, they're smart enough to actually continue around the corner rather than just default to either a stop state or a not getting stuck state. But yeah, that's going to be the main focus of tonight, is going to be trying to, again, refine this concept so that we can have enemies still act independently of one another, but be smart enough to actually pathfind around corners. And if that works, then we might move on to just very basic obstacles. Okay, Dr. Nicholson's there at the gym. Okay. So, in terms of how we'll do that, we'll go back to here. We have these different sections sections of code that are useful in different circumstances. So right now we have no nodes, enemy only moves to the left. If I were to deactivate this and do one node only, what you would see is what we had before. So you notice how the enemies are going to that corner, which is, you know, what we want here, because if a situation where an enemy is chasing after us, okay, we round the corner, enemies go to the node, and once they round that corner and they have line of sight again, since that's why they're shooting rectangles at us, then then they go back to the normal pathfinding. So we have that. It's just that, as you'll probably see, the one node per enemy idea isn't scoping quite correctly. So they both go to that node, which is actually what we don't want. What we want is that enemies go to that node and the other enemies go to this node. So, not quite scoping correctly. So we'll go back to the simple pathfinding while we, since that has the least opportunity for things to get messed up as we mess around with the code. Well, copyright from the way I see it, every little bit helps, you know? Now, where is it? Here we are. So, first thing we do is, whenever I'm trying to do something complex, I always like to write things out. It helps me organize my thoughts a bit. So, as we saw with our goals from last stream, let's restart the numbering. Anyway, so we managed to get enemies able to have multiple instances, which is good, and they can attach to, well, so that's the main thing we accomplished last stream. In terms of goals to tonight, so enemy get multiple enemies to act independently of each other while pathfinding to around a single corner to reach the player. And comprehensible, so that's why I was saying, you know, every little bit helps. If you're able to do what you can, that's perfectly fine. But yeah, to reach the player, we also want to get to a point where multiple enemies can pathfind to different areas independently of one another, while also successfully locating the player if the player is in a movable space for the enemy. Alright, those are kind of the main goals. In terms of ideas to reach these goals tonight, well, actually, the stretch goal would be a remix of what we saw here, which would be pathfinding an enemy collision box. That says must be attachable to an enemy animations object, so this would be the Cobra animations, and from there, any further goals would be more so the Cobra implementation. So, ensuring enemy collision box has collision properties and anti-stuck, i.e., from player jumping / falling. Alright. Alright. But yeah. But our main focus, of course, is just the pathfinding thing, because if we get that working, not only does that open up a lot of possibilities, but I feel like the other stuff will be more straightforward, because this kind of stuff has sort of been done before. It'll be curious to see how effectively we're able to make it stay next to the collision box, but I feel like in terms of how the Cobra is supposed to function with the animations and stuff, that's already programmed. It's just a question of making it work with the collision and pathfinding and all that. It's more so, again, the pathfinding. Now, in terms of how to approach this goal, I was thinking of primarily two ideas. So, idea one is what I will call we'll say points and custom point nodes. And let's make this side ideas. So. And while I was at idea two is to use enemy data retrieval. We'll say enemy data retrieval array. Node storage. And I was saying, okay, Anton, what are these ideas? Let me play them out. So these kind of focus. When I was rethinking about kind of our problem here with the multiple one node per enemy, it all comes back to the for each object. So for those of you who were here last stream, you remember be saying that Clickteam Fusion 2.5, one of its drawbacks is it's really not good at automatically instancing objects. What does that mean? So instancing an object means that if I have two, well, in this case, if I have two rectangles here, so we have our two collision boxes, they should both follow the same rules, but be able to act independently of each other. And that's what we currently have here. So you notice how that one's saying, the logic here is if there's line of sight, so if that projectile stand hits the player, then they move into 8-directional movement and should just move straight towards the player. Whereas if they don't have line of sight right now, then they should just go to their alternate movement condition, which is just standing still in this case. Okay, fair enough, Nicholson. So right now these objects are instanced because, as you can see, that one's staying stationary while this one's able to track after us. So they're able to act independently of each other. That's instanced. If they weren't instanced, then what would happen is, as this one is chasing me, this one would be moving either like exactly as this one's moving, or it would get stuck or be janky or do weird things. And that's generally a consistent problem with Fusion, is it's not the best at instancing things. Now, is it possible to just copy over the same object twice and then make all... Now, why... Sorry, I should back up. Why is instancing important? So, with instancing, it means I can use the same set of code for multiple enemies and they'll behave the same way, which is good. Because it means I only have to make one chunk of code for a particular enemy type, and then I can just copy-paste as many enemies as I want throughout the level, and they'll all act as they should. But if that instancing is not there, then that means I have to copy entire segments of code for multiple instances of the same enemy, when in reality they shall be following the same set of rules. So, why does that matter? Well, Fusion 2.5 also has some limitations in terms of how many lines of code you can have per frame, mind you. Again, not per application. Per application is different. But per frame, I think the limit's something like 20,000 lines of code or something. Now, to be fair, we aren't anywhere close to hitting that line yet. I mean, we're not even at 2,000 yet. But with the thing about Heartwell is a lot of the RPG mechanics can easily take hundreds, if not thousands, of lines of code, especially once we start adding more weapons. So for perspective, I think like line of code just for like the fist melee weapon is anywhere from like maybe 20 to 30 lines of code just to get all that working, and that's not including just how the stat menu works. So anything we can... So basically what I'm saying is any unnecessary copying of code for multiple things that should be able to use the same set of code, we don't want that to multiply up and cause lag or performance issues when we can try and optimize for it now in the more design phase. Oh, glad you're enjoying massages, Copper Nicholson. Anyway, chat, if I've lost you, let me know. I'll try to scale back my explanations here to be a bit clearer. But that's why object scoping is so important, especially at this stage of development, is for optimization and also ensuring that we can make the most of the resources that we have here. Because Fusion 2.5 is still a very, very solid software development system, but like any piece of software or programming language, you have to work within its constraints. So, that's my main point. The node finding objects, well, not the node finding. The biggest issue we're having is trying to scope the node finding objects and the... So, where is it? Yeah. The enemy collision objects. And the... Yeah, so trying to combine... No, not that. Where is it? I know the node's here somewhere. Oh, there it is. Okay. So yeah, trying to scope the node finding objects and the enemy collision boxes together has proven to be really quite challenging because they don't instance well together. Now, originally we tried to do this by having like a middle ground where it would attempt to scope, where we would attempt to scope the node finding objects and the enemy collision objects to each other, and that didn't quite work because, again, it's anytime we have a situation where we're trying to input data we're trying to instance data between two objects, the for each object can only really focus on one object at a time per line of code, so we have to avoid we generally want to avoid lines of code where we have to write a variable from one independent instance of object A to one independent instance of object B in the same line of code. So these ideas I was kind of thinking about off stream are both tie into that concept, but in different ways. So idea 2, it was actually ironically the first idea I had for this, which is, okay, we know that trying to instance between, we'll say, object A and object B directly has complications with the for each object, since we're trying to do instances and instances. So the idea with idea 2 is to get rid of the information in object B and instead store it in a singular object that can have all the information just instanced automatically, or not instanced automatically, but like located automatically directly to the instancing of object A, since object A, with every single instance, it has an index number that's individually associated. So we have like object A-1, object A-2, and so forth. So in this case, the idea would be to use an array, specifically the enemy data retrieval array, to store the x and y coordinates of a particular node and have them be recalled by the collision box. So the way this works, collision box has every instance of a collision box has an index value that is unique to it. So 1, 2, etc. In the enemy data, at the start of the frame, in the enemy data retrieval storage array, well, similarly, the same applies for the node objects. So we learned last stream that the node objects are in fact being instanced properly, so it's proof of that. See that counter down there right now is a 0? I put over this one, it's 0 as expected. I put over here, it's 1, 0, 1. I programmed the mouse so that for the mouse pointer here is to tell me what the index value is of a particular object that's over, if it has multiple instances. So in this case, I'm over the first node. It has a value of 0, which means it's the first instance. This one has a value of 1, which means it's second instance, and so on. We can see a similar thing here with the collision boxes. So 0, 1, 0, 1. So we know they are properly indexed. It's just not jiving well to facing each other. So, to the idea. Is a node different from a modal node? I'm not sure what you mean by a modal node, Copper Nicholson. Can you elaborate a little bit so I can I'll try to answer a particular question you might have. And while you're elaborating, I'll keep writing here. So at the start of the frame, in the enemy retrieval storage array, store the x, y coordinates of each node object in the array using the following. Sorry, X and Y coordinates, so they should be separate information. Using the following array coordinates format. So enemy index +1 34 if X coordinate, or 35 Y coordinate, Z axis path, view of enemy data, retrieval, storage array. Okay, good question, Captain Nicholson. So what's the definition of a node here? So in this case, when I'm saying a node, I'm referring to the node objects that we created last year. In this case, these green rectangles, or node finding object, I should say. In general, we could define a node as any point in space that has defined coordinates. So you can think of like an XY chart from like an algebra class. If you draw a point at, say, the coordinate x equals 1, y equals 3, well, that point would be a node. So, does that help you understand a little bit, Copper Nicholson? So in this case, what I'm saying is, at the start of the frame, we store the x and y coordinates of each node finding object in the array. And the reason why this might work effectively is we store the coordinates here in the array, and then at the start of the frame and after the previous line above, write the x and y coordinates in the array to each individual instance of the enemy collision boxes, using the following data array coordinates format. It's going to look very similar to the one above, which is one minor change. And the only change is right here. So instead of the node finding object enemy index, we would do the enemy collision box enemy index. Oh, it's at the coordinate system. So that's exactly what a node is. It is a point on the map, as you put it, where it has some kind of significance. In this case, in this particular place, it's a place the enemy should move to if they can't quite see the player, but the player's still in a walkable space to them, as a means to avoid obstacles. So here, what I'm basically saying is we take the XY coordinates from each individual node finding object, we store them in an array where their location in that array is tied to the node finding object's enemy index. So maybe slot 1 is for node finding object 1, slot 2 is for node finding object 2, and so forth. And then we collect that information from the array using the index of the enemy collision box, well, each individual enemy collision box, to get the XY coordinates for their node written to their ultimate values. Alright, no problem, Copper Nicholson. Enjoy your massage, dude. Hey, no problem, Drekor. Thank you so much for dropping by, dude. How's it going? So, we are actually picking up where we left off last stream, Drekor, so we're working more on the pathfinding here. right now, I'm just trying to write out my thoughts in terms of the ideas I have, in terms of how to approach this problem. Ooh, sounds like fun, Grasswork. Cool. But yeah. So if you recall the last stream, Greco, where we had some issues with getting these objects to index correctly to the node find objects when looking for different nodes, because previously what we wanted was this one to pathfind to that one, and this one to pathfind to that one when we can't see a player. Now obviously we didn't quite get to where the for each object came into play and was causing some bugs. So, the second idea, the reason I'm listing it like this isn't because it's the order I came up with these ideas, it's more so the order of which ones I want to try. And the, we'll say, backup idea right now is to actually use an array as sort of a middleman of sorts to store the information of the node objects, XY coordinates in individual slots that can then be read individually by the enemy collision bots indexing. Now that is the idea I would try if the first idea doesn't work or has too many complications. Now you might be saying, what is the first idea, Antomicx? What do you mean by custom point nodes? Well, if you can think of idea 2 as saying, okay, object A and object B aren't wanting to communicate well with each other by instances, so we'll add a middleman to make sure that they can each communicate by each other via instance. Idea 1 is essentially just getting rid of object B entirely and replacing it with something else. Now you might be saying, hold on, Antomicx. We spent a decent amount of time getting rid of, programming the node finding object. Why would we want to get rid of it? Well, consider this. The node finding object takes up a couple of lines of code, for starters, in terms of how it instances. And this might be needlessly complex for what we're trying to do here, because, I mean, think about it. The only purpose of this object is to give an XY coordinates for the collision boxes to move to if the player doesn't exist. That's its only purpose. It serves no other purpose. So, the thought with this is, okay, if its only purpose is to give an XY coordinate, if we can find some other way to provide that XY coordinates without an object, then not only have we saved ourselves one active object, but that also means we've saved ourselves the many instances of said active objects that would have been needed if, say, we had like 20 Cobras on one particular level. Imagine, that would also mean we might need like 20 of these node finding things, or 40 if there's multiple corners, or 60, or so on and so forth, and that just scales up. And while Fusion can handle multiple instances of the same object much more easily than it can handle different objects, that's still not good optimization if we can avoid it. On the other hand, if we can get that XY coordinates to be applied without the node finding object, it might, it'd be a good optimization. It might be more easily tailorable. It might also just be easier to program. And if we're going to take the time to move around a node finding object anyway, that means it would probably take a similar amount of time to just say, move the mouse cursor and say, okay, I need this coordinate 528.17.10, and then write a line of code pertaining to that particular coordinate. Because ultimately we have more lines of code to work with than we do have objects to work with. So, all that being said, premise of the node finding objects. Remove the node finding objects and replace with a line of code that defines the x and y coordinates of a particular node, of where a node would need to be for the enemy collision boxes pathfind to. Now you might be saying, okay, Antomicx, so if we get rid of an active object, well, if we get rid of the node finding object, then that means we can just communicate straight with the code itself, and that might be easier to program within the for each object. But how do you make sure that the node finding object only applies to particular instances of an active object? So for example, how do we make sure that if I wanted this thing to have a node that's here, and this instance to have a node that's here, how do we make sure that those coordinates are, properly entered without saying, okay, well, object 1 gets this node, and object 2 has the index of this value, that's this node. Is that possible to do that way? Yes, but do we want to do it that way? No. So, the way we might be able to do this has to do with areas. And by area, or more specifically, as it's called in Fusion, zones. So, you'll probably notice that a lot of these paths are fairly separate from each other. And like, if I were to move that thing over there and this one over here, you could probably draw a rectangle around this particular area that defines a space that these can move in, and a different rectangle around this. And while those rectangles were to overlap, the actual paths where the enemies can actually walk would not. So, actually, you can kind of see that right here. So, with the enemies here, if I were to move that enemy there and that enemy there and say, okay, if an object is within this zone, so let's say, we'll call this zone 1, then its node is this point in space. But if the object's instance is in zone 2, then its pathfinding node is this point in space. And because we can make it so that even if the zones overlap, the actual walkable area of the enemies never overlap in zones, then it might be possible to just have the programming language automatically put in this information for us without having to go line by line and say, hey, enemy 1 goes here, enemy 2 goes here. And that's important because if we have multiple enemies that need to work within the same pathfinding area, then that's better as opposed to just doing, again, copying code, as said before. Program. So to just write that down for posterity. Program zones where rectangular areas in the frame at the start of the frame where enemies will be instanced to particular nodes based on their location in the frame, i.e., if enemy collision box 1 is in zone 1, then it's S and Y coordinates, node coordinates should be the S and Y coordinates of the node for zone 1. This would scale certainly any collision box 2 is in zone 2, then its SY coordinate should the node in zone 2, and so on and so forth. Oh, what's up, Grepor? Yeah, question? Yep, we managed that in D2. We got a single enemy's Pathfind to work basically perfectly, and that was using the, I think it's called the Pathfinding object. Which, mind you, has practically non-existent documentation. Yep, that's correct, Rector. That is correct. And it all comes back to interactions with the for each object and how the Pathfinding object works. Well, Rector, that may sound strange to you, but again, it's one of the limitations of the software. I know some other programming languages, you know, instancing objects is just an automatic thing. It's not something you really have to think about. With this software, it's definitely something that's one of its more challenging limitations. Now, to be fair, Rector, again, the workaround for that would be to just copy multiple lines of code for the pathfinding, but since the pathfinding line of code is like 50-some lines of code or something, that's just way, way, way too much to scale up, in my view, without causing optimization problems. And also, it would just make it a real pain anytime there's more than one moving enemy on a particular frame. And by frame, I think of frames as like levels in a dungeon, so if I say, if there's a certain area that doesn't involve a loading point, we'll consider that a frame. I mean, Rector, if you recall the levels that I was designing before, and just, you know, how each floor is like so massive and has all these different interconnected areas. Imagine yeah, you probably remember that. So imagine having to copy a section of code for every single individual enemy that requires pathfinding. That isn't that entire frame. Exactly. It's tedious. It doesn't make any sense. It would make creating, you know, doing more complex level design where you're naturally going to have multiple enemies that can pathfind a nightmare, and that's like not what we want. So, and that's why we're going through this process in the first place. At the start of frame, I just thought of an idea. If we can get the enemies, like the enemy pathfind objects, to just automatically identify where they are just by their zones, we might not even necessarily need... Well, no, I think... Will we need... Okay, we might... Yeah, we either might not need a alterable value on the enemies for storing those XY coordinates to go to a node, if we can just tie it to a particular zone, so that if the enemy's just in the zone, they'll automatically say, hey, this is my node because I happen to be in the zone. Or we could get to a point where we still use that node for information, like those things for information, but there's some logic to where, depending on which zone the player is in, like relatively speaking, it changes which node the enemy goes to. Both have promise, but we need to actually see if this would make sense in the first place. But I'll just at start frame program the. So we'll call this option 1 at the start of the frame. Program the enemy collision. Program each instance the enemy collision box to have its XY node coordinates written in their alterable values based on the zone they are located in. Option 2, have enemies automatically move to a node based on the zone they are in. Can experiment with chaining together multiple nodes for enemy pathfinding by also checking if the player is in a particular zone. All right. I think that's enough theory crafting for right now, chat. Let's actually get into trying to make this idea a reality. All right. And again, because we'll be, yes, even though we're doing some indexing here, this is basically irrelevant at the moment for our testing purposes because we have the basic movement applying right now. So right now, the game doesn't really consider this in any meaningful context unless you're to activate a different section of code. It may be prudent, in fact, to just create another subset of code for this, because this is a new idea. We'll call it node finding point node movement. One point per enemy. Favorite Melody Rising Revengeance song? Good question. I'd probably say it has to be this way. So that's just such a classic song. But I think, well, what was the other one? I think the Hot Wind Blowing is also really, really good. Even though that song is just for a DLC boss that's kinda just exists. But yeah. Record, don't interrupt, but like it has to be this way is the final boss song, and that's a fantastic song. It's not the Blade Wolf song, Copper Nicholson. The Hot Wind Blowing is the song that plays for Blade Wolf's, we'll say, last boss in the Blade Wolf DLC. It's a really good song. I'd highly recommend you listen to it if you haven't given it a listen. It's one of those songs that a lot of people who've played Melody Rising Revengeance probably haven't heard simply because they didn't play the Blade Wolf DLC. Exactly right, Copper Nicholson. It's a very good song. Really, really hype. Yeah, so as per usual, bring these on over. Since, how did I do this one there? Actually, why is it moving there? That doesn't make any sense. Alright, so we actually do need to kind of remove that, so it's... If enemies only move with line of sight, this code is actually incorrect, so now I'm looking at it. Because, well, I mean, to be fair, this is overriding this line of code, but it's still a bad practice to have that object in there. And I'll copy it over, but we're definitely going to give it a rework. Actually, wait, no, that's just the... I see, it's just the exact same line of code as this, minus that thing. So, 1 second, chat. Okay, sounds good, Rekor. Oh, by the way, speaking of goals, Rekor, how goes the job search, dude? Oh yeah, the Jetstream Sand and Sundown Suns are also pretty good. So is Mistral's theme. Mistral's theme is great. And of course, we can't forget, I'm forgetting the name of the song, but the song for Monsoon is also fantastic. Like, Monsoon has a great battle theme. You sure, Drekwarp? It's something you can do in the background, dude. And it's really something you ought to be doing. I guarantee your mental health would improve immensely if you made progress towards that goal. And I gotta believe that a therapist is probably gonna tell you the same thing, like, hey, this is really bothering you, dude. You gotta take steps to work towards it. Alright. So, beyond our room, F's node finding objects here. And instead say... Should we probably just read this second section of code entirely because it's just... Well, it's irrelevant for this particular set of code. We aren't tied to any particular object, we're just telling it to go to a particular check. And just to test it out. Yep, as expected, it's moving precisely as it oughta. Cool. Alrighty. So that works. We can activate that. We'll use this since it has some of the... Well, actually, no. The ironic thing about this is, this would actually work in tandem with this, because we're trying to test zones. So we actually do need this code active, just for the default check. So with here... Actually, wait. Now, we need a modification. We might still need the... Yeah, okay, I do think we still need the multiple values now. Oh, that's amazing, Rekor. What'd you find? We actually will kind of need this because it needs to be... we'll need the multiple values of our our thing here. So instead of X node mining objects, we would say values A to Z. Retrieve node X. Node X. Node Y. And node Y. Oh, it's actually fantastic. Glad you enjoyed it, Gregor. Also, hey, Stizzle, thanks so much for dropping by, dude. How you been? Like, oh yeah, no, I agree. Like, for individual objects, or for just rapid level design or rapid testing, Fusion 2.5 is fantastic for it. It's why I love it so much. Just, like, it's like, the way I think of Fusion 2.5 is it's slow to set up, but once you set up your system, you can just build things like that. It's really, really fast. It's just kind of getting to that point when you're setting up the infrastructure of this engine. Yeah, very true, Record. Oh, been a while. Yeah, how's development going? It's been pretty good since we're kind of busy with Pathfinding shenanigans. Also, hello, oh Shiny Golden Lotus, thank you so much for dropping by. How's it going? Welcome, welcome. Welcome to our dev stream, where we are currently working on Pathfinding. As we can see, sort of got working, but still have more to do. Now, if you're wondering why on earth are they going here, it's because we actually have that line of code active that's setting it to this one. So we might actually want to set these off for a second. I don't think I do anything else with this, so let's just inactivate these for now. Because right now, yep, exactly. That means it's working as intended. Right now, you're saying, Antomicx, why are they going to... Oh, sure, no problem. I'll turn down the music a little bit. 1 second. Alrighty, I hope that's a little better. Yeah, Shiny Golden Lotus. How you been? What games are you currently playing out of curiosity? It's been a while since I saw you, dude. Also, hi, Angie and it's Flip. Thanks for dropping by. Also, love the Pikachu emotes. They're very good. But yeah. I'll be saying, Antomicx, why are they doing this? Well, that's because right now, since nothing was written to node X and node Y, both of those values are 0, 0, and the location of 0, 0 and the level is, of course, the top left corner of the screen. So that's why they're both going there. So that's actually a good thing. We want that. Ooh, finished playing Firewatch. I've heard of that game. How is it? I've heard it's a really interesting, like, puzzle mystery game where the dangers, the fire are always approaching on you, so it's kind of like a time limit in a sense where it's like, yeah, it's a point-and-click adventure. Oh, there's this fire approaching, so you better work fast if you want to cover the mystery. Pretty chill stuff. Okay. But yeah, so for those who've never seen this before, this is Heartwell. Heartwell is a Souls-like action RPG, so lots of fun stuff here, like different weapons and tools and stuff we've been programming. Currently trying to get pathfinding for multiple enemies to work properly. So these would be collision boxes for potential mocking enemies. It's a story-driven game. You can finish it quickly. That depends on the case. Yeah. I agree, Grettor. Dorothy is a very adorable protagonist. I would not have it any other way. Aw, thanks, Grettor. I try my best. But anyway, since we have this set up, so we have it set up to tie up to node X and node Y, now we get into where the real experimentation begins. So, we'll call this point node zone. maybe point node zone, or point node zone defining, or no, point node zone locations. Ooh, awesome. Yeah, it definitely sounds like an immersive game for sure. Well, oh, hope y'all enjoyed it. Because, I mean, I do remember looking at that game before. Like, this was like, I mean, Firewatch came out years ago, so it was probably when I was still in college that I first saw it. I went, oh, that seems like a cool adventure. I never decided to buy it, but it still looked interesting. What do you think you'll play next, Giant Golden Lotus? Anyway, as I was saying, what we need to do here is define some zones to see if we can get objects to behave differently from one another. So I'm actually going to move this object over here so that we can kind of have two zones to work with. Initial thought is, we'll say, we'll actually have to write down some values now that I think about it. Zone testing. So 1 x equals y equals. Okay. Oh, we should say x1, y1, because we'll need x2 and y2. 2 equals. Alright. We have 511, 1677. Yeah. And for those who are wondering where I'm looking for this, in the bottom right corner of the screen, there's a little like arrow icon with some numbers. Those numbers are the x and y coordinates in the frame. 733 and 1905. Yep. Fair enough, Tom Nicholson. That's zone 1. Zone 2 will be 570, actually, yeah, 576, 1741. X2 equals Y2 equals. Alright, 798, 1971. 799, 1970. Okay. Now, the question might come up, okay, well, clearly these zones overlap, because you see these, because I did like the interior as of these rectangles for the zones. You might be saying, well, these zones overlap, isn't that a problem? No, because the collision boxes cannot bypass these barriers, so the way I've had these lined up, like, this box cannot get into this zone, and this box cannot get into this zone. And they have this, this width of a barrier preventing them from even getting anywhere near that. So, even though these zones overlap, the way it works is due to the way the paths are. This object will only ever be in Zone 1, this object will only ever be in Zone 2, so we're not going to end up in a situation where things get weird because they're overlapped in multiple zones. Those are the coordinates we need. And I think this might actually be a decent spot to take our first break. No worries, chat. We will get right into the point node zone location programming after the break. See you in a few minutes, chat. chat, welcome back everybody. It's time at this point node, zone locations to find. So, we'll start with... for each object. Maybe we can do a starter frame for this, right? I think we can. Did we ever do a starter frame before? We'll find out. Yes, we can. Okay. Alright, starter frame. We don't need loops. What we need is to define some variables. Here, x position to a value. So the x position is equal, well, going to have to be lower or equal to right 511. Sorry, 733. And greater or equal to 511. Y position to a value lower or equal to
remember all the happy times we had
1905 greater or equal to 1677.
very much alike.
Alright, so what we're doing here, chat, is to find the first node. So saying it's greater than a low x value and lower than a high x value, and then same for the y value. This is essentially defining a rectangle where if any individual if an individual enemy collision box objects happens to be in this zone, then we're going to define the node, the point node for it. So in this case, I'm now realizing we actually do need to write down. So zone 1, that's great. Actually, we might want to do zones.
All right. I'll tell you the truth.
Point nodes. Point node 1. That's equals y equals. Now, chat, if this doesn't reinforce the importance of the documentation when developing games, I don't know what will. But this is we go to the frame, the XY coordinates of that. Well, I think they're around the center there. So we have 535, 1703. That's probably good. Then we'll also have 775, 1943. Okay. Try to find some values. Set node x to 135. 1703. And then, because of the beauty of Control-C, Control-V, we can just input different values for the next, for the other node. Alright, 775, 1943. And don't worry, chat, I know I have to find a different region for this. Okay. Okay. Do we need 576? 1941. 799 and 1970. All right. Let's see if it works. Yo! Yo! It worked! It actually worked! Let's go! Let's go! It worked, chat! It worked! It actually worked! Yes! Let's go! So much yes! Ah, and it feels so smooth too. It's alive! It's alive! Yes! Oh, this has potential! I knew it! Okay. So, you might be saying, well, Antomicx, why do we bother programming it like this? Well, look at this. Let's say, for the sake of argument, I want to have 2 enemies over here. Well, you'll notice it automatically tells you which node it should go to based on the location it's in, and I can have multiple enemies in the same path. Like, isn't that cool? So it's like, that's all that's happening in the background, just, The potential is real, chat. Alright. But for now, we'll keep it at that for the sake of simplicity. So, what this means, chat, is we can basically yeet the node finding object at this point. It's no longer relevant. Let's make sure to write a little note for ourselves here, just as a reminder. And commenting code is super important, because I guarantee, and this has happened to me before, sometimes when I go back to my earlier sections of code, I have trouble following what my thought process was because I didn't write as many comments back then. But now it's like, it's becoming more common practice for me to just write comments everywhere, so I can, yeah, exactly. The point nodes, our friend, chat. Point nodes for the win. Okay, so this group defines point nodes for enemies for pathfinding enemy collision boxes when in particular zones. Rectangles defined by 2 sets of XY coordinates. It works as follows. Start a frame. Define the if an individual instance of an enemy is in a zone defined by 2x and 2y coordinates. Well, we're not eating the nodes tabernacle, so we're eating the node finding objects because it's now irrelevant. Like, it's like this basically completely, this works better, it has less complications, it also saves us on some objects. So I'm probably just going to end up deleting the node finding object and some of the logic behind it, because again, that line, since we know this works, and it works really well as we're seeing here, there really isn't a reason for it to exist. Well, yes, the nodes are found, but it's a different kind of node. It's a point node, not a node finding node. Then define that enemy, then set the alterable values x node and y node to an xy coordinate for that zone, defined in the line of code. Alright, I think that's a decent enough explanation to at least give me the basics of how this this process works. So, since we know this works, the next logical escalation of this would be experimenting with chain together multiple nodes. And I say, Antomicx, in what circumstance would that ever be necessary? Well, in our level design sections, there are actually a number of instances where there's like a squiggly path an enemy might need to move in. So, what might that look like? Let's say I'm going to deactivate that line for a second. Actually, no. Let's activate this line for a second. I'm going to do some experimenting. Down here. I can very easily foresee a situation let's do another one of you. Overlay it like this. Alright. So, no, Copper Nicholson. I have not had that happen before, but it definitely sounds like you're relaxed in that case, which is good. Oh. Anyway. So, we could easily end up in a situation like this, where we have a sort of a squiggly path that the enemy needs to move through, especially a tight spot like this. And this, this would be a very common place for something to get stuck. So right now, as you can see, it's defaulting to 0, 0, doesn't have a node defined, which is fine. We haven't defined a node for it yet. But you'll notice, okay, so he's chasing me, that's all fine and good. I run around a corner real fast. Well, now he's confused. Well, I mean, he'd be confused anyway because he would just, yeah, it's kind of stuck there. I mean, I can probably demonstrate this more if I just... And activate that, and activate the default movement. What would... Well, I mean, actually this would just give us... it would stop moving. But what would happen is the enemy would just kind of get stuck. So obviously it's defaulting to just standing still, doesn't see us. But you would easily have a situation where it would be on the other wall following us like this, back and forth, which is not what we want. We want to be able to be reasonably smart enough to actually get to us, no matter where we are. So this might require a little bit more thought, shall we say, in terms of where we put our nodes. But it's also where we can start experimenting with, we'll say, chain noding or node chains. And whereas the other type of node is defined just at the start of the frame, this would kind of be more so a thing that is just checked for based on the player's location as well. So, undo that. Activate that. Alright, looks good. Okay. So then activate that one, because that was for the previous test. We'll need some more coordinates. So we'll need just that coordinate, and I'm thinking since this is an S shape, we could probably get away with a coordinate like there and there. And here. And the reason that is because that's kind of at like the apex of these corners themselves. So the enemy should be smart enough to move out diagonal to a particular position, provided there aren't any other obstacles on the way. And if not, then we can do even more, like maybe there, 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 and there. But I think we might be able to get away with just two if we're clever about the placement. So. Let's grab some coordinates. We'll call this zone 3. Point node. Well, actually, we'll need a zone 3-1 and a zone 3-2. And you might say, why Antomicx? I'll get to that in a sec. The idea of us having multiple zones. Yeah, I think that should work. Would that work? Yeah. No. No, it's actually defined by where it... Actually, no, we can reuse this. I'm just kind of, my head's in a thought process right now, trying to think, okay, we need to, it matters not just where the enemy is, but also where the player is. So we'll need both this information. Basically, these are both mini zones within the bigger zone, so in this case, what I'm thinking is, think like the top half of this rectangle is zone 3-1, the bottom half is zone 3-2. And that's all to help define where the enemy should move. based off of the player's location. Yeah. All right. Call it point node 3.1. That'll do. Let's just have a template, just to keep it simple. Okay, first our main zones. Say that's 688, 1998. About midpoint of that. 797, 2111. Actually, let's try 798 just to be safe. Actually, the X1 and Y1, we could probably just reuse this. So, then working smarter, not harder. Let's go down here. $688, 2226. Alright, that should work. For the initial definition. Now as for our point nodes, we're only attempt with 2. If that doesn't work, then we'll add more until it does work. I'm thinking let's try there and see if it works. So that's 777, 2071. And this will be 710, 2150. Alrighty. let's make our code. Oh yeah, it is 801. So, out of curiosity, chat, while I'm working on this programming, what are you all doing on this lovely Thursday evening? At the moment, anyway. Still working on that Sudoku puzzle, Drekor, or finishing up your massage there, Copper Nicholson. I hear one with the multiverse. Okay, Copper Nicholson. Okay. All right. So, this is no longer a star frame condition, because this is kind of more like an active node section thingy, shall we say. So say x is less than... Hey Drekor, welcome back. I'm not AFK, silly. I'm fine. I'm busy entering coordinates. Yep. I'm in a deep thought of just entering numbers, but it's numbers with a purpose. Is 777 and 2071. Yep. That's if that object's in that area, and then for the other one would be if the object's in the other area. Now, what these lines of code will only do is it's only going off of where this object is located. So I'm already imagining there will be some areas where the objects will get confused, so we aren't accounting for the player's relative position yet. This is more so just for testing to make sure that this idea of swapping between nodes works. Oh, I see Copper Nicholson. I see. Sounds like a very productive night then. Cool. Oh, you Copper, where are you? Sorry, where about you, Drekor? Where are you up to? And you'll probably say it on the ticket, Copper Nicholson. Oh, cool, Drekor. if it's alright to ask, what does the background involve, Repcore? 11, 10, 21, 50, okay. There we go. Alright. So, if done correctly, we should have it. Oh, well, hopefully this isn't lag things. Okay. Don't see any lag. Alright, it did move to the first node. That's a good sign. Good sign. Oh. Well, that's a problem. That all has to do with, relative location of things. Yeah. So it is properly moving to the node. It's just kind of, we can easily have a situation because this is what happens with corners. Yeah, I honestly think, because of that cornering issue, I think we might be better off with a more like in things like this, because then it will be less likely to do that, I think. We might have to end up having 4 nodes here. But for the sake of argument, if we lower our friend here over this way, we lose sight. Okay. This is progress, chat. This is progress. Because what I did was I defined 2 nodes in this within this larger rectangle. One node's there, and they each have these own little mini regions where those nodes apply. So you'll notice if I have this guy's attention one up here, lose track of him, he goes there. Now let's do a little test. What I'm going to do, chat. No, come back. I'm going to run around this corner as quickly as I can and see if it can follow me. So, boop. All right, it's something. Still doesn't quite see us, but at least got around a corner. I think if we had a node for every single corner, it would probably work better. So, node there, node there, node there, node there. As opposed to node here, node here. Because I'm seeing, like, you know, we have a cornering problem. Just with the way the line of sight check works. So you end up in a situation quite easily where the thing gets stuck. So, like this. Which is not what we want, that just kind of looks silly. It's also very easily exploitable, so... Now we're on it. A Souls-like game, any kind of little advantage you get is something you look for, but we can do better than this. So... Also, another potential problem is that if we're, like, kind of right on the fence here, and then, like, run around quickly around a corner, they might go to the wrong node. Just all the more reason to have more nodes. So... Alright, no problem, drive safely. Alright. I'm definitely imagining in my head, chat, we might be able to once we get to the point, well, first let's make sure that just having form. Actually, no, this might. I mean, we will need to define the new node locations, but since we've proven that we can get to a point where an instance will move independently to different nodes by moving between zones, what I'm thinking is this might be the time to start experimenting with the whole idea of multi-node chaining. So the idea being, in an ideal world, chat, what I would want is if a player's like in a movable zone here. So let's say I'm all the way down here, and this thing's like in that corner. This enemy should be able to pathfind to me, like, you know, squiggly around. Even though it doesn't necessarily have a line of sight on me. Now, in order to do that, that's what I mean by multi-node pathfinding chaining. It's just basically going from point A to point B to point C, point D, point E, and then to us, of course. And to do that, we have to, with our lines of code, we will have to take the player's position into account. So first, we'll gather the XY coordinates of these different nodes, of these different corners here that we see. And from there, good job, Hopper Nicholson. And from there, what I'm thinking is we make checks to see where the player's XY coordinates are, and then we try to optimize into like a single algebraic equation that can account for all potential nodes that this particular enemy type might face. So instead of having like 4 lines of code that would define like, okay, if the node's here, they go there, if the node's here, they go there, so on and so forth, it might actually... we might be able to have one line of code that just defines automatically what the enemy's node should be just off its location. But I digress. That's a thing we'll have to test. Alright. Hello, Sputkin. Thanks for dropping by, dude. How's it going? Welcome to the dev stream, and I'm happy to say we've been able to successfully instance point node finding between individual objects, so that's great. It's now a question of making our pathfinding work in more complex situations. So we can officially instance 2 L-shaped rooms, which is great. And now we'll just try to expand upon that idea. Yeah, what's new, Spot Tip? Oh, no, Spot Tip, no. So, what you're seeing here, this is very much behind the scenes thing, so none of this is what the player would see. What the player would see would be more akin to this. Well, they won't be able to see that, I just left that on for testing purposes, but they'd see enemies that look like this. You know, they have their own little animations and stuff like that. These rectangles you see is more behind the scenes, like collision boxes, hit boxes, things like that. So we're very much in a experimenty, testy phase. Let's grab that info. Alright, node 1. Alright. Still on SS977, we just change the wide coordinate to like 2021. Finally, this will have wide coordinate's going to be 2111. Yeah, like 2204 should be good. In terms of zones. Yeah. Oh, hey, Input! Thanks for the alert. I really appreciate it. Oh, hope you're doing well. Let's see here. One thing I realized in chat is that I'm already starting to think of mathematical expressions that might be able to make this easier. So let me just we should probably write down just potential mathematical equation idea. So we'll say node finding, or sorry, points node multi-chain equation. We'll say X node enemy collision box is equal to we'll say X1 plus X2 increments X2 times if player is in specific zone plus X3 times if I'm sorry to hear that, Ian Blue. I hope it gets better over time. Yeah, it is algae season for sure. All right. If you're saying, what are you doing here, Antomicx? So the intention here is that we're tying what the coordinates of the node in the object is to the player's location to an extent. Oh, actually, better yet. No. What we do is for this to work properly, we might actually need to, if player is in specific location and if enemy collision box is in specific location. Now, in an S shape like this, the thought I could think of is we would have one equation that would define what this should be based off some booleans, checking where the player is. So, and all this, mind you, applies if there's a line of sight. If there's line of sight, then all this is just ignored. So what would happen is let's say our collision box friend is, we'll say up here, and the player's like here. Well, what that would be is we have Boolean 1 is sudden. I would call this, so that's Boolean 1, that's Boolean 2, and Boolean 3. Boolean 1 would apply for the enemy, whereas Boolean 3 would apply for the player, and thus, under that particular condition, the x node should be whatever the x coordinate is of this particular node, so the enemy knows to move there. And then as the enemy is moving there, their node changes based off of the player stuff, again, using this kind of logic here. I'll do experiments with it a bit, but let's see if we can make it work. So we'll inactivate you. Actually, it may not inactivate, we'll reprogram this. And for the node, again, so what we should do here is just define the bounds of the overarching area. So we'll just make the entire rectangle, the beta rectangle, to say, hey, if it's this particular section, then it applies with this logic. Yep, no, it's definitely allergy season for me too. I find myself sneezing occasionally just because it is allergy season. Which is fine, it is that time of year. Okay. So this just applies for the full thing. So as it currently stands, it will always default to there no matter what part of the region we're in. So if I'm like down here, we're chasing us around. It should still default to, yep, it's defaulting up to up there. As you see, it's trying to move straight towards it. So if I move this enemy down here, it should still default to moving straight up there. Yep, working as intended. Alright. Now, let's do some logic. Well, actually, we need we also need some player info here. So actually, I might want to move the player info to the top, because that way, if the player info just doesn't apply, then it doesn't bother doing the rest of the checks, which would be good. The player should be the driving force for a lot of things. So, player. Player. All right. So this is checking to make sure that both the player and the enemy collision bots are in the relative zone that they, of importance for this particular enemy. And if we want to do one better, we can even say, hey, then the player's Y coordinate, and we'll say Z coordinate has to be in a certain range, or else the enemy doesn't care. For situations where, like, okay, maybe the player's in like a rum, but like the player's like on top of some boxes or on top of some higher area than where the actual pathfinding enemy is, then we can use that as a potential check. But I digress. So this will ensure that this node only applies when player is there. So you'll notice it's defaulting to 0, 0 right now because its player isn't quite there yet. Second I move in though, now it's defaulting to that node because it understands that. Anywho, we could still have a star frame to define its starting position. Let's just put that in ideas. Could have a second line of code to define have the enemy collision box. To at the start of frame. Oh, better yet. We could just have the node be oh, no, that won't work. Actually, it would work, just it's depending on the player's position. Alright. If player is not within a particular region, could have code to set the node X, node Y values. Collision box. So and have the code sets the nodes and the Y values of the collision box to its current X and Y coordinates to have it wait in place. Alright. I'll actually have 2 lines of code. So this line of code is about to look very beefy. I'll explain what the significance of it in a moment. The reason it's going to look beefy is it just because of the way I have to program the OR object here. I'm gonna have to repeat all this. So that seems beefy. It's because this is basically this is checking to make, basically saying if it's if the player's outside of a zone. Well, first, if the collision box is in a particular zone, so it only applies for that particular collision box, and the player's outside of that, then we have that collision box set node X to position, X coordinates, and Y coordinate. So in theory, what will happen is it should just stand still, and it does. Perfect. So enemies just stand still. That's great. Now we're in here. I'm in the right collision box, so it should, and it's standing still. Should not be standing still. should be defaulting to its node. I've clearly done something wrong here. Okay. It's causing some scoping issues. Okay. That was a nice thought. Alright. And we could probably just have it default to a particular node, and that would probably be okay. Let's focus on the main pathfinding issue at hand, which is just making sure pathfinds to multiple nodes. Okay. First, node X. All right, the logic here. X increments equals 67, Y increments equals, what are those differences? Honestly, probably go with 2201. That would, what would 191 look like? That would probably work. Okay. We'd probably go with 2030 and 2200. Do 2031. No. 2030 and 2202. Now, why that particular number? Because that is make logical sense. The 81. $2025. Oh, 97. So we're adding 86. I'm making increments, chat. This is just for algebraic equations here. Try and keep the equation simpler. This equation. X is equal to. Say that's initial equals. Y initial can equal 2025. X any, and X inch, and Y any and Y inch, just for sake of the equation. So X is equal to X any plus X inch, not zinc. Times actually, this is just the same equation we did before, but yeah. Player check boolean. Player location boolean 1. Might be similar, but here, because we have multiple, it's player location boolean 1 plus player location boolean 2. So that have to be a 0 or 1. Checking for a relative location of the player. Alright. Let's try X first because that's simpler since we only have 2 values to compare, so 777 over 710. Oh, cool, Dr. Nicholson, welcome home. So we could have not a Mets or so for here, it's simply if the player is in the zone 3-1, this applies. So we want to make sure that their y coordinates being checked actually. So y2 and y1. In this case, we're checking to see if the player is greater than, or lower than 2111. That'll be a positive value. Ah, fair enough, Rickwork. Hope you made some good progress though, that's what matters. You ought to be way more specific than that, Copper Metal Cinch, as the antagonists in Metal Gear games have such wide-ranging commentaries about things. So if I had to pick one that I think had the most interesting philosophy, it would probably be the boss from Metal Gear Solid 3. So that's a max value, but we want to make sure it rounds to 1. This whole expression checks whether the player is, if it has a Y coordinate of below 2111, and if it does, it yields 1. If it doesn't, it yields a 0. Yeah. Okay. That should make sense. This is all to start. We're going to have to definitely expand upon these equations. Since the way I'm logically thinking about this, I should see a situation where the player's on like the opposite side of the squiggly line and the box gets confused. Let's at least add some numbers in here. Actually, wait, I got this backwards. It should be the other way around. It should be Y player minus 211. As we want this to be true when the player is... Actually, wait, no, was it right the first time? Yeah, we only want... No, this is correct. So we only want this to be true when the player's like towards the bottom. Y coordinate wise. Where's the Y coordinate? bit more complicated. Alright. Y initials 2025. Alright, plus. Oh, no. I need that. I don't. There we go. Alright, no problem. Drop her into full swim. So our increment is 86, and we need multiple booleans for this. So obviously it should be nothing if they're like at the very top section. That's flare check and one flare check.